Right, hi guys, welcome to another episode of Bikes, Boats and Bits. Today we've got a little machining project, which we'll show you in a second. So we're going to hopefully get this camera set up a bit better so you can actually see what we're up to on the lathe. So we've got 4 parts to make, so if we can get one of them from start to finish on camera, then you'll get an idea of what we're doing, okay? Right, these are the parts that we need to do. As you can see, we've got an awful lot of studs sticking out on these shock absorber mounts, top and bottom. So what we want to do is make some form of nuts up that also includes a spacer. Now as you can see, the shoulders are all different as well, so we know these are just over 25mm and the bottom ones are just over 30mm, so do 2 different sizes. The idea being the thread comes more or less flush with the back or slightly protruding. So yeah, that's what. Right, what you'll see here is I've marked the end of the bar up. I've got 25mm precision ground 316. We're using that because A, it's nice and shiny, it doesn't rust, and B, we've got some. So I've marked it with blue marker, pen, permanent marker, one of these. So what we do next is I've now set the dividers up, so I'm going to spin this up to mark where we're going to take our first turn-ins to. As you can probably see on there now, we've got a nice scribe line, so that's where we're going to take our first cut to. And to put a 19mm hex on this, we need to turn to 21.93mm, so basically 22mm. So we've got to lose 3mm off of the OD. So we'll start on that now. Right, so first of all, we're going to touch off. So we'll spring them over, start the lathe. That's us now touched off. So we'll zero the dial. Say 21.93, so basically just over 3mm cut. So we'll take a 0.5 cut to start with, which will take a millimetre off the OD. So I'll just put some cut sauce on there. What I'm going to do now is measure this with the mic. So we have 23.95. I don't know if you can see that, but that is sort of halfway between 23.99 and 24.0. So that's a whole mil taken off. So we now want to go another one of those. So we'll cut compound on. So we're now looking at 1mm overall, so it'll be a 2mm cut. So we'll be coming down to 22, so yeah. This will be 2mm off overall, so we'll be 23. So that'll leave us a mil and finish off. Actually, I'm just going to slow this down a little bit on the cut. So we can try that. mic him again, so we should now be at 23mm. Now if you can see that, 23.05. So far so good. So we'll take another 1mm cut, which will be half mil on the dial. That will put us about 0.4 off. So 1.5 there. Then another little dot. 22.05. Measure that again. Yep, 22.05. So when we're looking for 21.93, so we've got basically 0.1 to come off. Now go 0.04. Quite difficult, but we should be able to manage it. That should give us our finish. We'll just check this one got hot. Nope, all good still. That should us now be on our numbers. 21.91, we needed 21.93. Call that a result. Centering. What size it is, but certainly small enough for what we want to do. Now on this particular lathe we've got a scale on the slide here, so it makes it easier to know how deep we're drilling. Always allow for the end point, of course. So we'll lock him off there, and we know we've got to go. We're going to make this pump 30mm, so we really want to be at least 32 just to make sure we're clear. It's important to take your time. Don't be welding drill bits in. Just come out every so often just to clear the swath. So, blow it down if you want, put some fresh cut paste on. 33mm. Now, tapping size is pretty much 8.5mm. We're doing a 3/8 per 24 UNF, so by 24 is almost a 1mm pitch. So 3/8 is 9.4 something, thereabouts. So hence we googled it anyway, and it came up 8.5. So just get it back in there. Right, so I'm 8.5 in a bit. That part of the process complete. Normally for this I use my verniers, but used them yesterday and the battery has died on them, so can't actually use them at the moment, which is the downside of having digital readout but verniers. So I'll just mark this up. That's the 10mm line right there. Now we're on 22mm more or less. We'll take this down to 16. Just touch off. Zero this. Seems to like half-mil cuts. So we'll do that. Don't want to push it with stainless because it has a nasty habit of going bad very, very quickly on you. Stainless obviously work hard very quickly, so you don't want to get it too hot. Right, let's just get this first pass. Off the part, so that will now put this on just shy of 20mm. Try not to leave it rubbing like that for too long. So 19mm. Not critical, so it doesn't really matter, it's not a critical dimension in any way, shape or form, but I do like to try and hit my own numbers. So we're looking for 16mm. So that is 1702. So we just need to take .4mm and we are there. Sorry, 0.5mm now. We'll have a look just to see what we did land on, but pretty sure it's close enough. There you go, don't know if you can see that, 16 dead, so I'm well happy. I will have to invest in a 45-degree chamfering tool, but for now, I have to make do without. Again, this isn't critical, it's more cosmetic. So far, so stick them in the saw, cut them off, more or less to length, we'll give it a little bit, and then this one's ready for the mill. Right, after what seems like an eon in the power hacksaw, we have managed to cut this down, and we've cut it over length, so we've got 2mm to work with that, so we'll change the cutting tool again, face him off. Couple of other operations we've got to do, and then definitely going on the mill. Right, that's quick enough for the 10mm. Faced off. I think it's swinging enough just to get a chamfer on the end. Put a bigger drill bit in just to clean the hole up. Right, as we know, we've got a shoulder on some of these. Do go in with an end mill. So put some nice flat bottomed clearance hole, rather than going in with a drill bit and ending up with a taper. Just put a 1/2 inch end mill in, push it in, So now what we've got is a nice flat bottom hole. I'll get the parallel through there. Maybe or not. Let me do it. No, it's not. Okay, what we'll do, just loosen them up just a little bit. Hold parallel to the chunk nice and snug. Push into the parallel. So parallel up, and you should be holding that nice and square enough. Right. So for our next trick, like brand new set, Presto taps. We've got 3 taps in here if you're not used to tapping. We've got this one, which is number 1. I don't know if it should say on it. No, it doesn't. We've got this one, number 2. And this one is a plug tap. Now, the difference being is the taper. So you see the start on there is a lot less than the start on this one. This one goes back to here. This one only goes back as far as there. This one has no ground start at all. So that is basically for plugging bottom holes. So we'll start with number 1. I'm going to put him in the drill vise. Cut down some of the camera noise. We need him for Ron. Plenty of cut and paste on him. Another one of those jobs, just take your time. There's no rush. What you don't want to be doing is extracting broken taps out of holes, because that's a real pain. So what I'm going to do, just push him up, like so we'll get him to feed on. Yeah, it's taking it, which is good. So we'll just let that pull that in. Now, if you've got the confidence, you can try a bit of power tapping. But like I said, I don't want to be extracting broken taps out of here. But by doing it on the lathe, I mean, you can take it out now, it doesn't really matter, stick it in the vise however you want to hold it, and do it with a tap wrench. But what we've effectively done by starting it in the lathe is get it in nice and square. confident. It's going through there lovely now. So you might have a different way of doing this. I have the ability to power tap. I haven't. At the moment I don't do enough to justify the expense on proper power taps for cutting threads rather than doing this, or the collets to hold the taps either. So we'll just stick with this for now, it works. I mean, obviously if it was a full-time machine shop, things will be slightly different. I'm not even a qualified machinist, so I just do this as a hobby. And that's something you always have to bear in mind. I'm just lucky that I've got a nice big workshop to have this and a mill sat in with 3-phase. There's no mucking around with phase converters or anything else like that. It is all wired as it's meant to be. And in a moment I will find the chuck kit, take this out again, because I'll put it somewhere safe, as we always put them somewhere safe. Again, eventually I want to put a rack on the back there. This one's moving because it's always in the bloody way. Here. Yeah, I want to put a rack to hold. I've got another tool post to go on here. I've got a quick change tool post, so we'll get that set up at some point and see how we get on with that. It's on a rack up there to hold tool holders, and also to like chuck keys and various bits and bobs like that. Now, one thing we haven't done is face that off, but for the moment, as you can see down there, it's got a lovely bit of threading down there, and it goes through nice and clean with a flat bottom hole. So now that is ready for the mill.